Okay, last time we were talking about functions. We talked about how you could import math, and then you can use the math functions like math.pow, which raises something to a power, math.square root, which takes the square root of something. And we also looked at how you can define your own function. In this case, I defined a quadratic formula, passed in three parameters, a, b, and c. And based upon that, I calculated x1 and x2, and then I simply just printed the answers. Well, we're going to focus a little bit more on the functions because there's a lot more you can do with them, um, and then proceed from there. So, bring up W3 schools. I like to use this in conjunction with material from the textbook. Probably one of the best sites I think around for IT learning. And I went down specifically to Python functions. We already talked about this, where you can create a function. You don't have to have a parameters. And I think I did the example where I did my morning routine or drive to work. I forget what example I did last time. So to call it, we saw that you just call the function name and then put your beginning parentheses and closing parentheses. We saw that you can pass in parameters. So you specify f name here, and then we got these right here. We're passing in different parameters. Notice they referred to it as arguments. I like to think of them just parameters. It makes more sense. It talks about the difference here. See, a parameter is a variable listed inside the parentheses in the function definition. An argument is a value that's sent. Again, I'll just refer to them as parameters. You got multiple ones, as we saw with our quadratic formula. So we've seen that. Now this we haven't talked about. See, it says if you do not know how many arguments we passed into your function, add a asterisk before the parameter name in a function definition. This way, the function will receive a tuple of arguments and can access items accordingly. And we haven't talked about how to loop through a tuple and tuple. I might try to pronounce that, to be honest. We haven't talked about how to loop through that, but you see here, print the youngest child is kids 2, and kids has an asterisk before it. And see, it prints Linus. Now you might wonder, why is 2 printing that one? It's because it's coming in when you got your list here. It's coming in with a index of 0. So Emil is the 0th entry. Tobias is the 2nd entry, and Linus is the 3rd entry. See if I change that to a 1. You see we got Tobias. Problem with that is, if I change it to like 4, see we got an error. Later on, when we talk about how to access this, we can see that there's a way to query how many we have. So this is a very powerful feature of Python to be able to go through and put that asterisk there. When you see this with the bracket, again, you think of this as a list of items. And when you see the brackets there, that's referring to one particular one. Now, if you left it off and ran it, see how it's giving us an error because we're trying to concatenate a list of items with a string. It doesn't know how to handle that. Okay. Now here, And I never really use this, but it is available. Um, you can also send arguments to the key equals value syntax. You see right here, it says child 1, child 2, and child 3, but then the order here is different. I'm not sure why you'd ever want to send them with um, different order, to be totally honest. But it is there. Down here, if you do not know how many keyword arguments you pass in a function, add 2 asterisks before the parameter name. This way, the function will receive a dictionary of arguments and can access items accordingly. So this is a little bit more powerful for what you could use now. You see we got the asterisk kid there. And here we're not referring to a number, because a number, as we saw, will break if you put in a number that's not valid. You know, we had 3 items, 0 to 2, and I put 4 in and broke it. Here, I'm referring to this, and so then that accesses that directly. Now let's run this though. And run that. You see, we still have an issue, because if you're not passing in that parameter, you see how it breaks. So, but that feature is there. Now in this one, if you're calling a function and passing a parameter, fantastic, you just pass in the value. If, on the other hand, you're not passing in any value, like this third one, then you can have a default to this. And how you do that is you put an equals there. So for example here, if just trying to think of some example to write that I could do this. I draw a real blank. I got that. If I call the quadratic formula, so I got the right syntax. Two, three, four. And of course, I didn't put in something that's valid. The math domain error means I got a square root of a negative number. Let's try that again. 1, negative 5, 6 should work. So let me put that in again, even though that's what the second one will do. And you see that when I pass in the parameters, okay, it works just fine. But even when I don't pass in the parameters, it'll default to these values. So sometimes you may write a program where you want to leave off an option. You can also pass in numbers like that. Now you notice here, I left off the last parameter, and it took as default this. So depending upon what you're writing, that may be an option for you, where you just leave it off. And I suppose using the names then would be appropriate, because if you did have a case where you just want to pass in A and C, but B you didn't want to, then that using names we specified above would make sense. We haven't looked at for loop yet, so we're going to circle back around to this definition. But just generally, to talk about what this is doing, is it's bringing in a list of items, apple, banana, and cherry, and it's coming in as food right here. And then you do a for x in food, colon, and then you can print x. Now let's play with this a little bit because I'm just curious. Let's see, number and let's see, numbers equals 1, 3, 5. In numbers. Okay, so that part's working. That's not good. 1, 2, 3, 2 maybe. In good ID, when you press enter, it does the indentation for you. For it to be in the function, it has to be indented. So remember, that's an important feature of that. Let's see if I can add it. I'm just curious if I have to do a cast to convert it, or if it would be smart enough to recognize our numbers. Sum is equal to sum plus x. 1, 2, print sum. Okay, so here, if you're bringing in a list of numbers, then you can, again, refer to it there. Now, notice how this says number and this says numbers. And I'm passing in numbers. This name here does not have to match that name there. Now, we saw with some of the earlier items in this that you could specify the same name, but you don't have to. And then this is looping through. So it's going to the first number, then second number, then third number. And what I'm doing is I set sum equal to 0, and then I'm just adding each number. So originally it's sum plus 1, which is 1. Then it's 1 plus 3, which is 4. And then it's 4 plus 5, which is 9. Now this part is the part I really want to get to. This is how to return a value. So I'm gonna write a program, and I'll make it a physics where I'm calculating force equals mass times acceleration. So definition, force, mass, acceleration. That's weird. There it is indented when I pressed enter. Okay. Then oh wait a minute. I'm not in W3 schools anymore. Never mind. And so then maybe I'll change this to calculate force. And force equals to mass times acceleration. So fairly simple in terms of physics formula. And now I'm going to do a return. And you just do a return and then the name. Now they just have a calculation here, which is fine. You can have a calculation, but you can also return a variable name. Prints are not necessarily a great thing to put into a function. I did it last time just to give us a simple start for functions, but returns give you a lot more power. Not that this is a hard calculation, but now I never have to, if I put this in a separate library and I can import it, I never have to write the code again for calculating the force because it's already here. It'd be completely self-contained in that library, and all I do is call it, and then I could refer to it in my main code. At now I may have mentioned this, probably mentioned a few more times too, but when I was at IFR, we would all write programs to access the Oracle database. And in the process, we'd put all the information to connect to the Oracle database and log in and so forth. And one programmer, very insightful individual, the rest of us didn't even think about it, but he said, "No, this is stupid. We're all writing the same code, basically." And so he said, I'm going to write an object, which we haven't talked about objects yet, but I'm going to create an object that we can call, where you pass in the username and a password, and it does all the connection to Oracle for us. And so he did. And it worked perfect. It was so easy. You just imported the function, the library, the class. You know, there's different names for it, but it's the same principle. And that's what this import math does. Somebody has went off and wrote the square root, the POW, so you never have to worry about that the rest of your life. You can just call it. And so we would import Dave's library, for example, if I had saved them all in a separate library called Dave's library, and did all the appropriate configuration to bring that in. Anyway, that's why you never put a print in there, is because the idea of code reuse. And when you do print, that implies you're writing it specifically for one program. So then down here, let's see. Math. Excuse me. Input mass. Acceleration input. And then after that, I'm gonna call mass, but it's gonna return something, which means I have to assign it to something. Now, different ways you could do it. One way, you could throw it inside of a print. This is called composition, where you put one function inside of another function. Calculate force m comma a. You could assign it to another variable. So I could have a force var equals calculate force. You can have these. It's just returning a value. So you could have it as part of a calculation. Like I take calculate force and times calculate force. You could. I'm just trying to show you how flexible it is. Math.pow, like I said, do the composition of functions where we put one function inside of another function. Like that. Let me just run those, make sure they all work. Three, four. Didn't like something. Let's see. 3 and 4. Let me see. M equals that. A there. Okay. Oh, I didn't convert them. Okay. What is float? They were coming in as strings. This is part of, I could operate off of a script. It'd make my life a lot easier. But I really want people to see how's programming really like. Programming isn't, this glamorous area where everything works perfect and so forth. It's just sometimes like going through mud, error after error. If you don't like to see errors, you probably shouldn't go into programming. 3, 4. Okay, still something wrong, but it got further. Okay, so 12, ran that just fine. Did this one. And yeah, that looks right. How expected 2 arguments got 1. Oh, well, that's definitely an issue. Probably other issues, but we'll see. I guess that was it. Okay, now I left this other one here for a reason. You see, you can have multiple functions, and it knows which one to call. Now, later on, we'll see how you can call a function over and over. And we'll even see recursive functions. If you're wondering how a function works, is it creates its own little space. You see here, I'm referring to this variable called force. And then when I call it down here in this print, let's then print the value of force. Blew up. Error after error this morning. And I'm not sure if it gives us meaningful names. Here it is. It does give us a meaningful name. Name error. Name force is not defined. When we use this variable name in our function, this is referred to as local. Some programming languages refer to as a local variable. It means it can only be accessed from within this function. It cannot be accessed over here. So I cannot do that. Now let's try it on the other hand. Let's this in that's defined here, let's try to access it up here. So I'm going to do a print a. Run that. We get 3, 4. Okay. Input mass, acceleration. And then down here, see how I printed 4? So it could access it here. This is declared down here as global. Now, it's not good programming practice to actually just put m times a here. You want to do parameters, pass it in. Because the idea behind that is that then it's completely self-contained. It does not rely on me actually declaring something in my program called a. Even though you can do this, it should be a minimal amount when you do that. And it should be never be used for code where you're going to want to put it into a library for reuse. Now, one thing, I'm not sure if they actually talk about it here. Well, they don't talk about it. That's a shame. You can return multiple values. So let's say I want to write a program to simplify a fraction. We haven't talked about the for loop yet, but that's okay. There it goes. Don't worry about the math portion of this. This is not requiring you to have a lot of math knowledge. Anything I assign, I'll make it pretty basic in terms of your formulas, in terms of the math. Some people start stressing out when I start doing the math. Okay, but numerator is equal to float. Float, maybe an int. Assuming int is the cast. Cast means convert from another type. And I'm going to say input numerator. Denominator, int input denominator. simplify, oops. Simplify fraction. And we'll be passing in the numerator and the denominator. I'll say n and d. And don't know if I need to have them as separate variables. I don't think I can modify the parameters that are coming in. So let me say numerator is equal to n, denominator is equal to d. Let's see if I can remember the syntax. I start all the different languages start running together. I think I'm teaching C, C++, Java, Python, JavaScript, Swift this semester. So yeah, this is invaluable for me. Let's see. Okay, that's what I want. X in range, and it's not 6, so it goes from 0 to 5. So for X in range, the numerator, so if I'm say in, if numerator I don't think I want that. I think I want this for X in range. So I'm going to go to n down to 2 and by minus 1. I think that'll work. Okay, let me clean this up a bit. Let's see. First off, let me just print X and see if that's going to go through. And call simplify fraction. Pass in the numerator, denominator. And didn't like something. What's it? Oh, I'm not using those. Didn't like that. So it should work, hopefully. So I clicked it. So it's still running from the previous one. It's still running from the previous one. Okay. There we go. 2, 4. Okay, doesn't like something. Simplify fraction numerator denominator. And 32 -1. That's working there. How come I don't got it working here? For X in range in, which I'm passing in. Oh, yeah, it's working. I just passed in 2. Okay, let's pass in something that's meaningful, like 5, 10. There it goes, 5, 4, 3. And I want it to go down. Let's go to 1. Five, 4, 3, 2, 1. Okay, now the procedure on that is to see if numerator and denominator are both divisible by x. If they are, then you divide it. So I'm going to say if numerator, modulus in Python. Let's see. Google's my best friend too. So Python modulus operator. I think it's a percent. Yep, percent. So if the numerator divided by the x, and this gives us the remainder, is equal to 0. That means it divides into it evenly. And it's either going to be an and or a double. I think it's probably double. And denominator, percent x is equal to 0. Then numerator is going to equal numerator divided by x, and denominator divided by x. Let me run that just to make sure it doesn't come up with any errors. Doesn't like that. How about ands? Okay, so 5 and 10. No errors. Now, let's do a return here. And instead of returning one value, I'm going to return numerator and denominator. So down on the receiving end down here, you could, I'll say num answer for numerator answer, and denominator answer is equal to simplify, or I got it right here. There we go. So print numerator answer slash denominator answer. Five, 10. Reduces it to 1/2. That shows something more complex. 800 or 640 over 820. That reduces 32 over 41. Now, don't worry about the math behind this. I mean, you'd have to really be in the math to probably understand what in the world I'm even doing here. What I want to demonstrate is that if you need to pass in multiple parameters, that's something we've seen already. But if you need to return multiple values, that's fine too. Just something to keep in mind. There's learn Python. And back to functions. I think I closed my window. Okay, so that they don't really present that here. I don't know why they don't have a section that says you can return multiple values. I wrote a program yesterday in Python demonstrating it for another student, and I returned 5 values. So if you're wondering, well, is there a limit? I don't know. It definitely goes up to 5. I've never had to return more than that. But anyway. Pass statement, function definition can be empty, but for some reason have function definition, no content put in pass. I don't know why you ever do that. Recursion. I'm not very good at recursion. But let me talk about it. This is going to call try recursion. So it's going to call try recursion. I'll just call it try. And k is going to equal 6. Comes down here, it says if k is greater than 0, which it is, then it's going to take the result is equal to k, which is 6, plus, and then it calls try recursion. So it's calling itself with k minus 1. So it's going to call it again with 5. It comes up here, calls itself, comes down here, see if it's still greater than 0. It is. So it calls itself again with 4. And keeps on going, calling itself until it hits this the 0. And it comes down here, it says result is equal to 0, return result. So then this returns the value of result back to the previous call, which then returns the call back to the previous, which then returns that to the previous, returns that to the previous. I wonder if I can find you an example maybe it makes a little bit more sense. Let's see, recursion, adding numbers. Not very good at them, so that's why I'm having to cheat. Oh, perfect. They even got Python. I was gonna have to, thought I was gonna have to switch it over. Okay, so let's take a look at this. $15. Okay, so it's calling recursion sum. It's passing in 5. So this then checks if n is less than or equal to 1 to return n. Otherwise, it'll return n, which is 5, plus. So it's adding the next number. And then this is going to call the recursion sum again with 5 minus 1, which is 4. Comes down here, and it's like in a buffet when you got the plates that are pushed down. When you call itself over and over, then it's storing it on something called a stack, and then it pops it off the stack when it's done. You should avoid recursion as much as possible. Some cases you can't if you're writing a system library, if you're going to computer science. The system library that accesses folders, for example. There's no way for you to avoid using it. There's other times when recursion is necessary also. But system libraries or system software is probably the most popular use of recursion and mathematical formulas. You might say, well, why don't you just use a for loop, assuming you knew a for loop? Well, yeah, exactly. Problem with this is, if I change that to 500, I'm guessing it won't work. And I would have guessed wrong. Let's try 50,000. There we go. That's what I want to do. I want to break it. Maximum recursion depth exceeded in comparison. Your stack has limited amount of memory. And so if your program is such that you're asking the person to input the number and then there you're doing that. This is very slick coding. I'll give you that. Recursion, it's just clean in some ways, but it also can cause you system errors, as you're seeing, because you keep using more and more memory each time you call itself. Then eventually it'll exceed that. Anyway, the whole purpose of recursion is, or the whole guideline, I guess I should say, is you're going to have two return possibilities. One is where it's calling itself, and it's counting down to something, going down to 1 or something. Factorial is a popular example of this. I bet I could do factorial because now that I got this code. Factorial, it's like if you got 5 factorial, that's 1 times 2 times 3 times 4 times 5. Factorial is a very popular one to program in many programming classes. Okay, so if I wanted to calculate 5 factorial, I'll put a 5 in here. And let's change this name to factorial. And I'll call that. And so I got fact here. Now, these are just multiplied together. And I'm starting at 5, so I'm going to be going down. And so it follows the same format here. It'll reduce it. But instead of the plus, it'll be times. And let me think about this one. If n is less than or equal to 1, I return 1. Yeah, that should work. In theory, you just need equal. I'm not sure why they had less than, to be honest. Should give us 120. Yeah. Now you can program them differently. You could have it start at 1 and go up to 5. So if I start this, how would I start at a 1? That's an interesting idea. You'd have to have a variable for start, I think. Maybe you can't go from 1 to 5. Like I say, I don't. My mind doesn't work very well in recursion. I wouldn't lie and say it does. But anyway, that shows you a couple examples of recursion anyway. Okay, let's see here. That was kind of wrapping up on what I wanted to show you on functions. They introduced functions fairly quick in the book because we're going to find in Python one of its real advantages is its usage of libraries, of functions. Oh, excuse me. Okay, now here's a case study. Some pretty good information. The turtle module is kind of fun. We have time at the end, we might take a look at it. But I'm going to go down to conditions in recursion. We already talked about recursion. This is just out of the book. And I already talked about the modulus too. Now, when you divide, let's talk about this. Some of these operators here. I did a pure check for the. Let me get rid of this. There we go. I did a check for the remainder. So let's say print, and then division 3 divided by 2. Print remainder. Maybe 3 divided by 2 isn't a good one for the remainder. 5 divided by 2. That's better. So if I run that, and 7, 14. Oops, I didn't do my percent. That's a modulus. It's a math thing. Get 2.5 and 1. But let's try another division. And 5 divided by 2. When you put two slashes like this is integer division. If you think old school, way back when, 5 divided by 2 is 2 with a remainder of 1. So if you're trying to access the 2, then that's how you do it. Okay. Modulus operator is nice in mathematics. I'm not sure if I ever had to use it in programming, because I never programmed the mathematical calculations. Most of your work is business, manufacturing, tracking like orders. I do have one student that works with GIS, and I'm thinking maybe that would have a lot of mathematical. I don't know. Now, we're going to be getting into doing some comparisons, and you need to understand Boolean expressions in order to go with that. And if you got equal here, this is checking to see if these are equal to each other. And it returns true or false. A Boolean expression will always return true or false. We got these down here. By the way, it's not unusual for equal to be equals. You're saying, why do they just put 1 equals? Well, 1 equals is the assignment, where you're assigning a value, perhaps. 2 equals is where you're doing a comparison. There's one programming language where 1 equals is the comparison along with the assignment. I think it's assignment 2. Visual Basic. Every other language I can think of that I teach has 2 equals, so you get used to it. Here is an exclamation equals. That's not equals. The some programming languages are less than and greater than. You can have a greater than, less than, greater than or equal to, less than or equal to. There's other items you can work with in terms of the Boolean. As you saw in my example, I added the and in there. Means both of these have to be true. So like this example here. X is greater than 0 and X is less than 10. So this will get all the values where X is greater than 0 and X is less than 10. So if you had, like, for example, X is equal to 12. X equals 12 is greater than 0. That's true. But then X is less than 10. It's not less than 10. So that's false. Both of them have to be true for the entire condition to be true. If you have an OR, like you have this says either one has to be true, or can be true, I should say. Means if the first one's true, then this entire thing will be true. If the second one's true, this entire thing will be true. Or if both of them are true, then it'll be true. The only time it's false is if both of them are false. Now the not operator. This right here, not x is greater than y. That implies that it's the opposite of x is greater than y, which means less than or equal to y. Now the not is quite useful. I cannot tell how many times programming I've used that, where I've had something complex. And if sales is greater than 5,000 and cost is less than 1,000, or cost is greater than 50,000, print, I'm here. So I have something more complex. Let's make sure there's no error there. Sets back to having declared those or assigned them value. Okay, yeah, those are not defined, but that's okay. You got a really complex if statement. And you find, perhaps, or maybe the internal customer calls you and tells you that the program is working exactly opposite of what it should be. And you're sitting there thinking, how in the world do I write the opposite of this? There's no way. Well, that's easy. You just put a not in front of it. You do this. If you go in for a computer science degree, one of the classes they have you take is a discrete structures class, where you talk about boolean logic. And I don't even remember all of them, but like if the sun is shining and my car is broke down. If I wanted to write the opposite of that, you might think that I'd write the sun is not shining and car is not broke down. That'd be the opposite. It's not. It's been a while. I think it's the sun is shining or the car is broke down. I could probably do truth tables and figure out if that truly is the opposite of that. Let's see. Sun is shining. Sun, car. 0, 0, 0, 1, 1, 0, 1, 1. One would indicate that it's shining, and one would indicate the car's broke down. It's like I say, it's been a while since I looked at this. The and is where you multiply them together. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is 1. So the only time the entire condition is true, that's the 1 here, is when this is 1 and this is 1, where they're both true. Okay, that makes sense, because we said the and. Now, what I propose here is that if I did the or, except for I think I want these as opposite, not shining, our car is not broke down. Now, not sun. These would be the opposite values of sun. So that'd be 1, 1, 0, Now enjoy this presentation because I won't be talking about truth tables anymore in this course. It's a little bit beyond this, but it does show you the power of the knot. And the knot broke down. A car broke down. If I flip the car to the opposite, that would be 1, 0, 1, 0, and the or between them. So that whole last statement. You would add these. That's what the or implies, except for 1 plus 1 is 1. And 1 plus 0 is 1. 0 plus 1 is 1. 0. Now that would imply, if you look at this, the 0, 0, 0, 1, these look like the opposites of each other. So if I put a, see, I don't got it right. I could put a knot in front of it, and that would work. But I could have put a knot in front of the original one. That's its challenge. This is why they included the knot. So if you're sitting there, well, I can rewrite sales greater than 5,000 as sales is less than or equal to 5,000. Yeah, you can. But I guarantee you will run across selection criteria that it'll take you a long time to try to figure out what the reverse of it is. And this gets around it. Okay. Now we're ready to start talking more about the if statement. So we'll do that next time, and go into working with boolean and so forth. And we'll see there's a lot of different things we can do with the if else structure, along with the looping. So we'll go ahead and stop there. I'll put an assignment out later on the functions, so that you can do something where it returns a value.